Hello friends, I am Professor Shreyas Sarola from Department of Electronics and Communication Engineering. Today in this lecture we are going to discuss about the BCD adder and the carry loop adder. So what do you mean by BCD first of all? BCD is nothing but it's a binary coded decimal. So when you start writing the decimal from 0 to 15 in terms of binary, you must require the 4 binary bits. But when you try to write the BCD numbers, it will be the same as a binary from 0 to 9. But if you want to represent 10, that means 1010. This will not be the valid BCD number. That are we call as a invalid BCD number. So to convert into the valid BCD number, you need to add a 06H to that number such that that number will be converted into the valid BCD number. Let's suppose take an example over here. I have the 15 and if I need to convert into BCD, here 1 will be represented as 0, 0, 0, 1 and 5 will be represented as 0, 1, 0, 1. That is what we call as a BCD number. There are the certain steps that how to find the number is valid or invalid number. That means when you add the two numbers, if this 4 bit, let's suppose the 2 BCD number which is of 4 bit if I am adding and the sum is equal to or less than 9, then it's a valid BCD number. If 4 bit is greater than 9 and if the carry is out generated, it is a invalid BCD number. Then you must have to add 6 to that number to get a valid BCD number. Now let us take example of an BCD adder. If you add 3 plus 4, it's a 7, and when you do the binary operation again it is 7. That means this number is less than equal to 9, so it's a valid BCD number. Now let us try to add a 9 plus 4, that is 13. In a binary it's a 1 1 0 1. This number is greater than 9. That means this number is a invalid BCD number. So what you need to do, you have to add a 06H to that number. So this is a 13 plus 0 1 1 0, we will get this number. This is nothing but my 3 and this 1 represent as a 0 0 0 1, that is a 1, so 1 3. Now this number will be the valid BCD number. Now how the BCD adder circuit looks like. Let's suppose if I draw a truth table based upon the concept what we learned, we have S3, S2, S1 and S0. There are the 4 bit sum. That means till 9 there will be no error. That means all are valid BCD numbers. But after the 9, when it starts, this 1 all represents as an invalid BCD number. Now if I want to design a logic circuit, I must have to design a Boolean expression based upon this truth table. So there is only one option, like draw the K-map. So you have a K-map S3, S2, S1 and S0. Substitute all this output on the 4 variable K-map and make a pair. So this is a one pair, that is S3 into S2. Here is a pair of 4 ones, that is S3, S1. That is output is equal to S3 dot S2 plus S3 dot S1. You must require 2 and get and 1 or get. So this is what the circuit I will get to get a valid BCD number. Let's suppose take the two numbers A0, A1, A2 and A3, B0, B1, B2, B3. When we add the two number, I must require a 4 bit binary adder. What is the output I will get? I will get a 4 bit sum and 1 carry out. Let's suppose if the number is less than 9, then is no problem. That means you will get a valid BCD number. But if suppose the number is greater than 9, what you need to do? You have to add 6. That is nothing. This is the concept. This is the circuit what we had get it from the previous truth table, that is for invalid BCD number. That means here this number will connect to the S3, S2, S3, S1 and the carry. That means if the carry is 1 or if any of the output is 1, that means this will set to 1. Now if this is 0, what it indicates? If y1 is 0, it indicates it's a valid BCD number. But if y1 is 1, that means it indicates it's a invalid. That means you need to add a 6 to that number. That means you already have the sum, 4 bit sum. Now what you are doing to add you must have to add 6. So how will you get the 6? Now this one I will add. You must require the 4 bit 0, 1, 1, 0. That means in between these two requires a 1. So this inputs, it's again the 4 bit binary adder. So 4 inputs are coming from S0, S1, S2 and S3. Another 4 input, that is a 1, 1 I got. Now to get the 0, I'll put this to the ground. So 0, 1, 1, 0. This is nothing but a 0, 6. That means this sum will be added with a 6 to get a 4 sum and the carry out, and this number will convert from invalid to valid BCD number. So this is the concept of the whole circuit about the BCD. Now the next topic we are going to discuss about CLA. It is also called as a carry look ahead adder. Now you know about the binary adder. What happens when you try to add the 4 bit, that is x0 with xy0 with carry in, output will be one summation and carry will be propagated to the next block. Again, when you add these numbers, carry will be propagated to the next. That means this carry need to wait till the previous carry is generated, and this carry is need to wait till the previous to previous carry is generated. So this is how it will increase the propagation delay. That means the total propagation delay of a carry out will be equal to the time taken with the carry 0, carry 1, carry 2 and carry 3, and finally I'll get a carry. So to reduce the propagation delay, we are using CLA adder to predict the carry early. That means if you predict the carry very earlier and the last carry does not depend upon the previous carry, that means you can able to increase the speed of an adder. That is what we are going to understand about the CLA, the carry look ahead adder. Now you look at over here the concept about this carry look ahead adder. This 0 1 0 0 1 1 1 0 0 1 0 1. Here when you do the operation of this A XOR this B, that is 0 1, you will get output as a 1. Now when you multiply this 1 with a 0, you will get a 0. That means your carry has been propagated. Here look at over an example. 0 1 output is 1. You again multiply this 1 with this carry is propagated to the output, that is for next block. Here take this example. If you do the XOR for 1 0, what is the output you will get? You will get 1. When you multiply this 1 with this 1, the carry in, again the carry is propagated to the next stage. That means A XOR B dot C in, that is an input carry. You will get a next carry then. Now what about this two condition? This two condition is nothing but A dot P, that is 1 dot 1 you will get 1, 1 dot 1 that is also get a 1. It does not depend upon the input carry. Okay. Now when I put it over here, the carry out, that depends upon the A dot B plus A XOR here. For this 2 it always remains a 0, so no need for this. So A and B plus A XOR B dot C. Here this is what we call carry generator. That means it will generate a carry, and this we call carry propagator. That means the carry what you have as the input, it will propagate to the output. That's why we call it carry propagator. In general, if I want to write, C out is a combination of G, that is for generator, P for propagator, and the carry in. So for n number of bits, I can write Ci equal to Gi plus Pi into Ci minus 1. This is nothing but a carry to the input block. Now based on this, I can write, this is C. For the C0, if I put I equal to 0, G0, P0, carry in. For C1, G1 plus P1 plus C0, substitute this value, and this will get these things. Again, when you write the C2, it will be C2 equal to G2 plus P2 C1. Then substitute this C1 equation on this C2. We'll get in this equation, and finally C3. Now when you look at the last equation of the C3, the third carry, there is no Boolean expression which depends upon the C2. That means if you have the input block carry, you can directly generate C3, C2, C1, C0 in parallel. What should be the diagram? It's simple. One AND gate and one XOR gate. And again for C2, same ways you can able to generate for C3 also. Now, what should be the circuit? This is the carry look ahead generator. You must require a P3, G3, P2, G2, P1, G1, P0, G0 and the C0, that is nothing but a carry in. Here, this summation is nothing but a A3, B3, that is look at over here, the C out. What do you have? A dot B plus AX or B dot C, that is A dot B, that is a generator. That means how will get a generator, that is a dot B. How you get a propagator, that is a AX or B, AX or B, AX or B, and the carry in, that is over here. Look at over here, the C4. Here, look at over here, that is a C0, that will be given with a P0 and this the carry in block, that is a propagator and carry in block. For this sum you require a P1 C1, that is a P1 and this C1 propagator. So C0 is a combination and P0 is XOR gate. So this is what you require. Once you get these things, this will be the easily you will get. That means here the carry look ahead order does not depend upon the previous stage carry. If you have a one carry, that is input carry, you can directly generate the last bit of the carry. So this is what the summations you have, carry generator. So if you have any questions, you can mail me on my mail ID, thesreyas.charula@marwadi education.edu.in. Thank you. Have a nice day.